A pie, good observation. Step 1. Okay? The next big observation that we could do to make this science is not just say pie, but write pie. Most of science that separates science from the rest of the world is actually taking notes. You mean writing? Yeah. Okay. Depending on the writing system and the point at which you're writing, okay, that is going to change the targeted audience. A lab notebook targeted audience is largely you. Are there secondary audiences to a lab notebook?
Yes.
Yeah. What secondary lab audiences?
Would be you as the instructor to make sure we're picking it up.
You could look at me as an instructor. I don't care. That's academia. That doesn't happen in the real world, right? Nobody takes notes in the real world.
It's like your peers miss class and they ask for your notes to see if they can catch up.
That's still cool, and I like that. That's still academia, right? You're like, the classroom is totally different than the real world. Learning mathematics in a classroom has nothing to do with your ability to do taxes in the real world. You should learn how to do taxes in class, not how to do mathematics.
So you might be doing an experiment, you have like a lab report, someone else who wants to do that experiment like goes off and see what you guys did wrong
Okay.
or what they did wrong.
Science builds. By writing up a lab report, somebody else can look at those notes and they could replicate it. If they replicate it, what does that mean about your result? It's more valid. Okay? So an accumulation of data could work towards that. I'm in the lab, working through something. Okay? We've got a bunch of people working around in the lab. I'm in the lab, I'm writing some notes, I'm writing it in pencil. I find the cure to cancer. Okay? Cure to cancer. This magical drug, this is what I do, here it is, everything's great. Buddy next to me is looking at my notes and going, yeah, that's really cool, dude. We should tell, you should tell everybody about that. Okay? Meanwhile, while I'm excited going around and telling everybody about it, he's copying my notes in pen. What happens?
His is better because it's written in pen.
Because his is in pen, the collateral audience, the judges, the court system, our bosses, think it's his idea. Because mine is in pencil, it doesn't get counted. It doesn't hold that same legal weight. And I lose all credit for having made that discovery. Okay? It's huge. Okay? So when we write notes, we're writing them largely for ourselves so that we can build and take notes and put out papers so that other people can repeat that. But we're also writing it as a permanent record. Okay? There's a need to kind of archive that information. Wink, wink, nudge, nudge. Okay? So the technologies that we use to take these notes become super important. Okay? So let's push this further. What does the optimist see? A whole pie. Okay, because they're saying, I got a whole pie, right? Because they like pie. That's the why behind their observation. I like pie, and I got a whole pie. What else might they see?
So favorite flavor?
Strawberries, favorite pie. Okay, why? It was their favorite pie. They like that. We see the observation, and we can tie the meaning to why they're making that observation. What does a pessimist see? Calories. Why does a pessimist care about calories? Because an optimist probably sees calories too.
Because they think that's a sweet and get that.
Okay? Optimist may see calories and be like, those are some tasty effing calories. Pessimist sees, those are some fattening calories. Same ultimate observation, but a different why behind that phrasing. What are you going to add?
The strawberries are whole and could be like hard and weird to eat instead of having a slice.
Okay? We got whole strawberries, okay, which could be harder to eat. For the record, the whole strawberries hold their flavor better. They are also prettier than if you sliced them underneath. I would bet they got sliced strawberries underneath and they put the whole strawberries on top just to make it look prettier. But you're right. Okay? What does the scientist see?
Ingredients.
Ingredients. Okay? Why?
Because what did it take? Reaction.
What did it take to make the pie? Why?
Because he wants to know the process.
Why do we want to know the process? I want to make another pie. And this is where scientists kind of push this little gray area a little bit and make it a little bit worse. Okay? Not only do scientists look at it and say, well, I want to make another pie, they actually have another motive behind it.
They want to make a better pie.
They want to make a better pie. A scientist sees a leaf and says, I can make a better leaf. So I'm going to study chlorophyll so that I can make a better molecule to absorb light that can do what I want it to do. Because I'm better than nature. Okay? So scientists are horrible egomaniacs. Okay? So they have this big why. So what are they going to do? We know the why. They've studied it. What are they going to do with that information?
Break it down to its base components.
Okay? But remember, the why. Their motive was so that they could make a better pie. They now know the basic components. What are they going to do to make a better pie?
They're going to experiment, patent their idea.
They're going to experiment. Okay? They're going to say that was white cane sugar in that pie. White cane sugar, while useful and pretty and all that fun stuff, doesn't have the same flavor. So I'm going to switch it up and use a little turbinado sugar, maybe a little brown sugar to add a little bit more character and backbone behind my pie. Those strawberries, because we're in the state of Arizona, probably got shipped from somewhere really far away, probably not as good, probably not picked at their peak season. So I'm going to go to California, in the middle of California, where they have strawberries. I'm going to go there in the middle of the summer. I'm going to harvest the ripest, tastiest strawberries, and I'm going to put those into my pie. We've created an experiment on how to make it better. Right? For the record, that change makes it better. They also see this crust and go, that was not a very healthy crust. That's just white crust. Okay? I'm going to make a whole wheat crust. They used butter. Butter's not very healthy, so I'm going to use... I don't know enough about making pies. Coconut oil. Okay? Crisco's not much healthier. But those are the two ones that I know, is butter and Crisco. Okay? I'm going to use suet, because that's what we had. Okay? Yeah, don't do it. It didn't work. Okay? So we go through and we tempt it. We build it, we test it, and we go, that was a crap pie. Okay? They failed. Okay? Does that mean they stopped making pies? No. They probably threw that one away. Okay? Or gave that one away. Here, have this pie, and then run. Okay? And they go back and they make a better pie. Or they change their experiment. So what scientists are constantly trying to do is they make an observation and say, I can do better. Okay? Or I can make better. There are other motivations behind that can be more nice and touchy-feely and all that great stuff. But at the bare essentials, that's really what's happening. Okay? And what we just walked through, what was largely the steps of the scientific method, which you've probably heard before. We start with that observation. That is a pie. Okay? But the scientist says, I can make a better pie. Okay? Which is technically a hypothesis. Okay? But really they're saying, I can make a better pie by doing what? Using better ingredients. Okay? So then what do? Because that happens a lot. Okay? It happens all the time in politics, daily life. I made an observation. I can do better. I have a better global policy than the rest of the politicians on the planet. That's where it stops. That's not frickin' science. Okay? What makes it better is we go to an experiment. We actually have to test this. We have to put it out there and see what happens.
You can't test your opinion.
Okay? A hypothesis is really just an opinion. We need to actually test and push this to see. What's the next step in scientific method? We can go with observing, yeah. Analyzing data, okay. I would still kind of group that with experiment. The results. We get a conclusion. Of that conclusion, we decide that we have a law or we have a theory, right? Nice linear process. That's how it's taught in the textbook. Okay? You guys were already throwing in some other terms that said that was crap, which is good. You said we observed. Where's observation? way back at the beginning. This is a cyclic process. Okay? I'm a horrible pessimist or realist, however you want to look at it. Okay? I don't think it goes to observation. What it goes to is my favorite 5-4 letter that begins, that word. It ends in failure. A horrible failure. So it goes back to a new hypothesis and a new experiment. Then what happens?
Failure again.
It goes in failure again. Okay? And scientists spend their lives in this circle. Okay? And when I say lives, I very much mean that. And that's one of the things that doesn't come across in a basic chemistry class. What you see is this nice straight line and go, I went through and did this experiment and everything failed, but everybody else got a theory or a law out of it. I must suck as a chemist. No, you don't. Just the other chemists didn't tell you that all they did was fail. And that 1% of the time they advanced to a theory, okay, or a law. Okay, so what you have to realize, and we really have to stop because the next class is getting irritated. What you have to realize is that we are spending our time in failure. Okay, and a big typo that needs to be changed there, that should be a little f failure. Capital F failure doesn't loop back, it loops to something else. Okay, it says, I suck at science. You don't suck at science. You're actually an awesome scientist. Keep failing.